Like, you know what I'm trying to say. I was just joking with you.
I know it.
All right, so, Hankelbrief. All right, hydrogen, oxygen. Your reference table should be out. I don't see everybody with them out. Hydrogen, oxygen, nitrogen, chlorine, bromine, iodine, and fluorine. Tristan, what did I forget to put in there? Twos. There it is. Twos. H2, O2, N2, Cl2, Br2, I2, and F2. You need to remember this the rest of the year, okay? When we get to particle diagrams, maybe next week, what does that mean? I'll be giving you worksheets. I'll draw boxes on the board. So worksheets with boxes on them or on the board. Now we'll say, draw a sample of nitrogen gas inside the box. And you're going to draw little circles. Some are shaded in, some are not. And the way you would draw any of these, so nitrogen is N2, is you would take two of those, two of the same, and draw a bunch of them spread out because it is a gas. So that would be how you would draw nitrogen gas. What is the point of that? Showing me, and then ultimately, yes?
No, I was up mine because it would glare on the...
Yeah, I'm gonna leave it. Is it real bad?
On the camera.
D? Yeah, well, yeah. Thanks, I'm gonna leave it though. I like sunlight. I like ultraviolet radiation. All right, anyways. Why is this important? You got to prove to me, prove to yourself, and in the regents, ultimately, New York State, that you know that's a diatomic element, and that's how you draw it. Okay? So that's why we're going over it.
Should we draw that?
No, not right now. So, why? Why do they have little twos?
There's two things.
Because they want the full valence. How do you pronounce it?
Valence shell, very good. Full valence, yes. So these elements are very unstable by themselves. So they find themselves, their mirror image, their partner, their clone, and they bond. And they form a bond, and that's how we draw it on paper. Okay? So F is not stable by itself, but it is stable as F2. There's two things that you'll hear me say a lot this year. Stable and low energy. Those essentially in science in general, but chemistry and physics specifically, which basically explains everything, because there's science and biology, there's chemistry and physics involved with that. But anyways, we could argue about that, I suppose. But stable means low energy. Stable means low energy. Okay, right now you are sitting, not a whole lot of energy going on with your body. But if you get up and run around, you have a lot more energy and you're less stable because you're moving. So that's just a simple analogy. But anyways, these are more stable, low energy, and that's why I introduced it early in the year. You need to remember that. Okay, this quiz on Friday, next Friday. It's not on symbols, it's not on the names. What is it on? Everything else you've learned. So this was kind of a struggle this morning. You tell me, what else have you learned? It's been 2.5 weeks. I didn't just go over the names and symbols.
Sig figs.
Good, sig figs. Actually not on the quiz, but you will have sig figs throughout the year on random quizzes. Like, it's something I expect you to know in like a calculation. But yeah, that's good. We have learned sig figs. Group names, good. What else? Atomic mass and atomic number and how to write that, right? So if you have calcium, it's 40/20. That's the mass, that's the atomic number. We learned that. What else? Metalloids. This side? Left side? So you got the metalloids on the staircase. What's over here? Metals, and then non-metal. Right, so you learned that. What else?
The father of it.
Yeah. Who was that? Mendeleev, right. And I'm going to write myself a note. I'm glad you brought that up. I gave period 2 bonus questions on that quiz you took last week, and I wasn't here for you guys. So I'm going to make up for it. On that quiz, I'll give you bonus questions, and I won't give them bonus questions. So I'll make it even there. I just wanted to let you know. So anyways, yeah, Mendeleev, good. What else? What else have you learned? Something I talked about like 3-4 days in a row. Kept saying the same term over and over. Brian.
The
Metalloids, oh, we got that. Thomas touched on it. Valence electrons, which is part of the electron configuration. Sylvia, you with me? Okay, electron configuration, right. So valence electrons, electron configuration. What number tells me the number of protons? What number up there in your reference tables tells you? The atomic number, right? You learned that. What else? Tesla coil, the zapper, the taser. Why was I playing with that? Just for fun?
Yes.
Yeah.
Well, yeah, for me it's for fun, but for you, maybe it's fun for you to watch, I suppose, but the point is you're learning what?
Science.
Science, yep. Properties, right. Properties of the metals and nonmetals. The piece of wood didn't conduct, but the metal did. The metalloid did conduct, right? Properties of metals, nonmetals, metalloids. We wrote those down. That's stuff you need to know for the quiz. And reactivity. Who doesn't react, and then as far as groups, and then which two are the most reactive groups? 1 in 17, most reactive metal, most reactive nonmetal. Who doesn't react? Group 18, because, Thomas? Group 18 doesn't react, because? Full valence shell, right, or a complete octet, depending on which one we're talking about, right? So that's a lot, right? And there's a lot of Regents questions. So it'll be multiple choice, all Regents questions next Friday on the important information. Yeah, knowing the name and symbol is important, but not as important as understanding what you're looking at, right? As far as trends and like why they're organized the way they are. So that's going to be next Friday. The only thing left to do today, and we got 12 minutes, is to learn these two words. Write these in your notes. This is right underneath the Hockelbrief.
Come on, Amanda.
This is the last part of the periodic table notes. Electronegativity, leave about 3 to 4 spaces here, or lines underneath, and write ionization energy. These are two phrases that if I was completely on my game here, but I'm not because I've been kind of out and leaving early and stuff, I'm a little bit all over the place. I would have remembered to put it up here. I'm going to eventually have a little box that says word of the week or word of the day or whatever. I would have put them up there yesterday, and then your homework would be look them up, define them, write it down, and I go around and check. So we're going to do that throughout the year. This would have been good to do it, but I didn't think of that yesterday. So anyways, we'll talk about it right now. Go to table S, as in S. Table S, on your reference tables. You need reference tables, or else you cannot participate, and that's not a good thing. They are in order. They go A, B, C, D, E, all the way up to T. S, find reference table S. Look at the top of table S. You're going to have to turn your reference tables sideways or landscape, or whatever makes sense to you. Table S, says it right on top, table S. Keep going, Cody. Keep going, keep going, keep going. Faster and faster, 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 faster. Keep going. There you go. Yep, that's the same one. It just is on 2 pages. All right. Okay, electronegativity is right at the top, in the middle. Everybody with me? Hope everybody's with me. Okay, you're going to look up the electronegativity of the following elements. You're going to write this in your notes here, okay? Ca, Fe.
Should we write it down?
Nope, exactly how I have it. Yeah, okay, we're going to jump up here. We're going to go P, we're going to go O, and we're going to go F. And then the same thing here. I don't know why I put that dash there, but K, Ca, Fe, P, O, and F. All right, I want you to look those up on the period or on the table S there. Kirk, do you need reference tables?
Yes.
Anyone else need reference tables? If you are not looking at table S, that is not okay.
No one.
So I need you to follow along and understand how to read these. All right, besides learning chemistry this year and a lot of other ancillary information, so hopefully I can help you out with some real life stuff, not just straight up chemistry. Also, you're going to learn how to use the reference tables. So if I say get out of reference table S or I or B or whatever, and you can't find a reference table, and then you don't tell me, then you're kind of shorting yourself, cheating yourself out of some knowledge. So anyways, please let me know if you ever need one. I got some up here and you can borrow. So look those up. Got 8 minutes left here. I'm going to use a basketball to help understand these words. All right, hopefully you're moving along here. Electronegativity for K. Caitlin Hall. Point what? Point E. CA, Raquel.
Wait, I'm not writing it.
Okay. CA
1.
1.0. That's a bad zero. F, Brian. 1.8, good. P, Ben King.
2.2.
2.2. Ryan, go ahead up.
3.4.
3.4. And fluorine, Amber. Say it again? 4.0, right. Okay. Ionization energy of potassium, K. Luke.
419.
419. Ca. Kurt. 540. Fe. Caitlin W. 7 what?
762. I thought
62.
CA was 5'9".
Yeah. Is it 5?
Okay.
It is.
I don't know.
I
I knew it's 5
I wasn't
something.
sure if I was wrong.
It's 5.
Oh, I thought you
That's okay. All right, 7.6. No, you're good.
Oh.
762. P. Sydney. 1,000 what? 1,012. Oxygen. Cal.
1,313.
So 13, 14. Okay. And then F. Bree.
1681.
1681. Okay. I keep looking at the clock. It's really annoying. All right. So if we start here, eyes over here. So we start here with these two, and we kind of make our way to FE, then we jump up a little bit, and then go to P, then O, then F. So in general, we're starting on the left, and we're ending up all the way on the right. Okay. So I want you to see that there is a trend with these numbers. So look at that, look at this. What is the trend, raise your hand, that you see? Amanda.
The numbers get larger.
Yes, very good. As we go left to right across the periodic table, these numbers increase. It doesn't matter what elements I picked, that's true for that trend. In other words, I could pick rubidium on the left, and I could pick copper in the middle, and I could pick Cl on the right. It'll go lower to kind of a little bit higher to much higher. They all increase as they move left to right, and there's a reason for that. We'll get to this one tomorrow. I don't have enough time to really explain this fully today, but we'll get through this right now. But one quick thing, does this have a unit? Because this does not have a unit. Does this have a unit? KJ/MOL, right? That stands for kilojoules. What's the prefix kilo mean? 1,000. J is joules. Does anyone know what that means? It's a unit for heat or energy. The word energy is right in this. Has anyone ever heard of BTUs? Like if you buy a window air conditioner, it might say in the box, 5,000 BTUs. Anybody ever heard of that number or that initial? It's basically how much energy that appliance needs. So like refrigerators, microwaves, washer, dryer, dishwasher, air, things have BTUs, like how much energy they use. Well, in chemistry, and that's called a British thermal unit. Anyways, that's kind of universal. Joules are what we use in chemistry. Okay, you won't really see that in real life, but that's how we kind of gauge how much energy something has. Like a banana has 400 joules, but a steak has like 2,000. So if you eat a steak, you get more calories. Calories is another word for energy. Joules, same concept, or unit, I mean. So anyways, I'm just introducing that. This stands for moles, and in chemistry, moles are important. Mole day is coming up, October. Big day, we'll talk about it. Okay, back to this. So electronegativity, here we go, ready? 4 minutes. So I'm gonna be potassium. Who wants to be fluorine? I'm potassium. Who wants to be fluorine?
Nobody.
You gotta catch the ball. Sylvia. Okay. Sylvia's fluorine. Okay, you can stay. You know, I'll get you. Or do you need to stand? Like for your catching ability.
No, I can catch
Okay, Cal, watch out. I won't hit Cal, but I'm, you know. All right, I'm gonna go high on this. So Granted, be careful.
Don't
Here.
hit the ceiling.
All right, now. So I'm potassium. This is 1 electron.
Wait, do you want a video?
Oh, maybe. Well.
I'll do it. Oh, I don't want to do it.
So okay, so this is one electron,
Where?
and I am potassium. Everyone go to the periodic table now. Periodic table. Look at the electron configuration for potassium. This is my 1 periodic table. This is my 1. What are you laughing?
Cody was like
This is my 1 valence electron. Find it, look at it, don't look at me. Look at the electron configuration of potassium. Miranda, do I want this?
Yes.
Why?
This is going to get you closer to a fuller
What's full? 8. Okay, do me a favor, look at the potassium electron configuration. What if I just happen to fall and drop my electron and roll away? Would that be okay? Would I then have a full valence shell?
No.
Look at potassium.
No, we don't need that.
Look at, oh, I'm sorry, look at K.
No, you don't need it.
No, because then you'll have a full valence shell.
If you get
I'm
rid
sorry,
of
you
it.
weren't with me. So now you're with me, right? Yeah, I'm sorry. I should have double checked. So now she's with me. If I lose this one, so everyone's looking at potassium K, right?
Yeah.
Okay, it's 2,881.
Yeah.
If I get rid of this, will I have 8 as my last number?
Yeah.
Yes, catch. Okay. Okay. All right. You're fluorine. Everyone look at fluorine. She just gained that 1. Why is that good?
Because
Because now she has 8. She was 2,7, right? So now she has 2,8. So I lost it, but I'm happy to lose it. She wants that electron more than any element, more than anyone in here. If she was fluorine and we were assigning elements, she's the strongest person in here. Okay? If I didn't give that to her, she's going to come over here, knock me out, and take it. That's what fluorine does. So what's electronegativity? What's electronegativity? Look at oxygen. How many valence does it have? 6. It really wants 2 more. Look at calcium. What's the last number? 2. I'll pick up with that tomorrow. That's unfortunate.
You can throw it again tomorrow.
Hey, I'll throw it again.